Grade 3, Chapter 12. Today we will be learning about fractions. So, what are fractions? Well, fractions are parts of a whole. A fraction can name a part of a whole. To write a fraction, each part of the whole must be the same size. Here are some examples. In this one, there are 4 parts, but only one of them is shaded. So, there are 4 parts in total and 1 part shaded. In short, you might be wondering, why is the fraction written like this? Well, the fraction is written as parts up here and the whole at the bottom. So in this scenario, well, it would be shaded over total. Now, what about for this question? Well, there's 2 parts that are shaded and 3 parts in total. So then that would be shaded over total. So when we read this, it would be 2 over 3 or 2/3. This one would be 1 over 4 or 1/4. Now, what about for unequal? Well, you can't write a fraction for unequal parts, such as this one. You can't write a fraction for it. Imagine, well, okay, this. Pretend this is equal, and then this is shaded. So that would be 1 over 2, which is, well, half, right? And then imagine your friend telling you that they're going to share a whole slice of pizza with you. What a good friend, right? And then they give you this much of the pizza. 1 part, and there's 2 parts in total. But it's unequal, so you can't really say it's 1 over 2 because that's not half at all. So let's do some practice problems now. Write the fraction for the part that is shaded. So you might not be able to see very well. So I'm just gonna draw squigglies in the shady parts for ya. So, almost done. How many parts are shaded? Well, 1 part is shaded, and there's 4 parts in all. So, what's the fraction? The number of parts over the whole. So, 1 part over 4 parts, which is a whole. So, the fraction that is shaded is 1 over 4 of the figure is shaded, or 1/4 of the figure is shaded. Now this one, there's 3 parts that are shaded, and 1, 2, 3, 4 parts in all. So the fraction would be 3 shaded parts over 4 parts in total. So 3/4 of this figure is shaded, or 3 over 4. Now this one has 2 parts that are shaded and 5 parts in total, 5 parts in all. So 2 over 5, or 2/5. We move on to the 4th question, where there's 3 parts in total and 2 parts that are shaded. So that would be 2 over 3. And question number 5. There's 1, 2, 3, 4, 5 parts that are shaded, and 1, 2, 3, 4, 5, 6, 7, 8 parts in total. I'm going to give you guys maybe a little bit of time to, well, solve it. So there's 5 parts that are shaded and 8 parts in all. So 5 over 8 is the answer. We're done section number 1. That was quick, wasn't it? Now we move on to section number 2. Problem-solving investigation. So the question here is, Danny and Drew were playing cards. Danny had 2 cards in his hand that equaled 8 and the difference was 2. Or the sum was 8 and the difference was 2. Drew held 2 cards that equaled 6 and the difference was 4. How do you know which cards they are holding? Or do you know which cards they were holding? In short, the question asks us, which cards were they holding? So what do we understand? We know that the question wants to know which cards Danny and Drew have. And we know that Danny's cards together equal 8, and when we do a subtraction, equal to 2. And Drew has 2 cards that equal 6 with a difference of 4. So how do we solve this? Well, first, we should write down what we know. So for Danny's card, I'll be using n and m. So n plus m equals to 8, and n minus m equals to 2. And for Drew's cards, I'll be using a and b. So a plus b equals to 6, and a minus b equals to 4. So which one should we start with? The subtraction or the addition? Well, we know that 1,000,002 minus 1,000,000 is also 2. So subtraction is not a good idea to start with. We should start with addition. And since we know what we are going to do, let's solve the question. What combinations add up to 8? Well, we have 1 and 7, 2 and 6, 3 and 5, 4 and 4, and then 5 and 3, and so on, because 5 and 3 are the same 2 cards as 3 and 5. So it's not necessary for us to write down all of them past a certain point. So what's 7 minus 1? 6. 7 minus 1 equals to 6. 6 is not equal to 2. What's 6 minus 2? Well, 6 minus 2 is equal to 4. 4 is not equal to 2. But 5 minus 3 is equal to 2. So 5 plus 3 equals to 8, and 5 minus 3 equals to 2. Which fits with which 2 cards Danny has. So it would only be logical to think that Danny has the cards 5 and 3. Or, well, you can also circle this one since they're the same combination of cards. And for this one, a plus b equals to 6. Well, what equals to 6? Let's pretend that none of the cards are 0, okay? So we have 1, 5 equals to 6. And 2 plus 4 also equals to 6. 3 plus 3. And of course, 4 and 2, 5 and 1. So now we do the subtraction. 3 minus 3 equals to 0. 0 is not equal to 4. 4 minus 2 equals to 2. 2 is not equal to 4. But 5 minus 1 equals to 4. So 5 plus 1 equals to 6, and 5 minus 1 equals to 4. This also fits in with the 2 cards that Drew has. So Drew has the cards 5 and 1. We check. So 5 plus 3 equals to 8, and 5 minus 3 equals to 2. That's right. 5 plus 1 equals to 6, and 5 minus 1 equals to 4. That's also right. So our answer that Danny has the cards 5 and 3, and Drew has the cards 5 and 1 is correct. Now we're done the second section. Congratulations. We're going to move on to the third section. Find the equivalent fractions. Now this one is fun, but it's also kind of confusing. So hang in there and pay attention. Equivalent fractions are different fractions that name the same amount. 3 over 4, these are what are called fraction strips. They are good for understanding, but to draw them out would take an extremely long time. So 3 over 4 is 1/4, another fourth. If you think about it, this is one part shaded, this is one part, this is one part. And that's 3 parts out of 4. So if this is one part and one part and one part, 1 plus 1 plus 1 equals to 3. So this one is 6 over 8. And 6 over 8 is equal to 1/8, 1/8, 1/8, 1/8, 1/8, 1/8. So 6 1/8. Which, as you can see, is equal to 3/4. And there's also 9/12, so 9 1/12. And that's also equal to 3 over 4. So 3 over 4, 6 over 8, and 9 over 12 are equivalent fractions. Now, you must be thinking that there's definitely an easier way to realize whether or not they are equivalent fractions, right? So think about it. 3 over 4. What does 2 over 2 equal? Well, if there's 2 parts and both of them are shaded, doesn't that mean that the whole thing is shaded, so that equals to 1? And we've already learned our multiplication tables, right? So what is anything times 1? The thing itself. It doesn't change. So since 2 over 2 is equal to 1, we're going to do that. So 3 over 4 times 2 over 2. In the multiplication of fractions, we multiply the top numbers, the numerators, together, and we multiply the bottom numbers, the denominators, together. That would be 6 over 8. Ta-da! So what would we do if we multiply 3 over 4? If we multiply both the denominator and the numerator by 3, well, that would be 3 times 3 equals to 9, and 3 times 4 equals to 12. Ta-da! 9 over 12. Essentially, the way that you can find equivalent fractions is to multiply or divide both the numerator and the denominator, the top number and the bottom number of a fraction, by the same number. So let's do some exercises. Complete each number sentence to find equivalent fractions. So in this one, we have 1 over 2. It's not that clear. And we have 2 1/4. So what is 2 1/4? 2/4, right? Equals to 2/4. Now, as you can see here, 1 times 2 equals to 2, and 2 times 2 equals to 4. And 2 divided by 2 is equal to 1, and 4 divided by 2 is equal to 2. So now we have 1 over 3. So 1 over 3 equals 2, and then there's 2 1 over 6s. What is 2 1 over 6s? 2 over 6. 2 over 6. So 1 times 2 is equal to 2. 3 times 2 is equal to 6. Both the numerator and the denominator, the top number and the bottom number, are multiplied by the same amount. Now this one might be a little bit trickier. So there's 2 1/5 here. So that would be 2/5, because there's 2 1/5. Equals to, there's 4 1/10 over here, so that would be 4/10. So 2 times 2 equals to 4, and 5 times 2 equals to 10. So we multiplied both the denominator and the numerator by 2. That is why these two fractions are equivalent, because the top number and the bottom number are multiplied by the same amount. Or, as you might learn later, they are the same ratio. Now we move on to the fourth question. 3 over 4 equals to something over 4. So what is 4 divided by 4? Well, 1, right? So if we multiplied the denominator by 1, and we have to multiply the numerator by the same amount, what is 3 times 1? 3, right? So the blank over here would be 3. Now, 1 over 3 equals to something over 6. What is 6 divided by 3? Well, 2, right? So since the denominator is multiplied by 2, then we must multiply the numerator by 2 at the same time. So 1 times 2 equals to 2. So 1 over 3 is equal to 2 over 6. Now this one, 2/5 equals something over 10. 5 times what equals to 10? Well, 10 divided by 5 equals to 2. So we also need to multiply the numerator by 2 since the denominator is multiplied by 2. So 2 times 2 equals to 4. Now we move on to the other question. 1 over 4 equals to what over 8? So 8 divided by 4 is equal to 2. So what is 1 times 2? Well, 2. Since the numerator and the denominator are both multiplied by the same amount. Now we move on to this one. It's the same 2, so we know that 8 divided by 4 equals to 2. And since 4 times 2 equals to 8, then we must multiply the 3 by 2 at the same time since, well, as I've said before. Then 3 times 2 equals to 6. 3 over 6. Quiz, guys. So what is 3 over 6 also equal to? Well, 3 over 6, Well, we know that 6 divided by 3 equals to 2, and 3 divided by 3 equals to 1. So if we divide both the numerator and the denominator by 3, then, well, we get 1 over 2, a half. So what is half of 12? 6. If you don't understand it yet, well, 1 times 6 equals to 6, and 2 times 6 equals to 12. And since the 1 over 2 is equivalent to 3 over 6, and since 6 over 12 is equivalent to 1 over 2, then they're all equivalent. Think of it as 2 is equal to 2 and 2 is equal to 2, so 2 equals 2. Anyhow, question number 10. We have 12 and 4. Oh, this is simplification. So 12 divided by 4. Equals to 3. So if this one is division, then do we divide the top one? Yes. Because dividing is like multiplication by a fraction, but we're going to learn that later. We need to do the same thing that we do to the numerator as a denominator. So if the denominator is divided by 3, then the numerator must also be divided by 3. What is 3 divided by 3? 1. Now we're done those questions. Yay! We have these questions now. Oh, look! 1 over 2 equals 10 over 12. And 1 over 2 is equal to 3 over 6. And 3 over 6 is equal to 6 over 12. So I guess we already know the answer to that. 4 over 5 equals to what over 10? Well, 10 divided by 5 equals to 2. So this divided by 4 must also equal to 2. And since we know that if something is divided by another thing to equal to, well, another thing, such as something divided by 4 equals to 2, then something divided by 2 also equals to 4. So if this divided by 2 equals to 4, then 4 times 2 would equal to this. So 4 times 2 equals to 8. 8 divided by 2 equals to 4. Now this one, 8 divided by 2 equals to 4. So the denominator is divided by 2. Then we must also divide the numerator by 2, because that's how fractions work. So 2 divided by 2 equals to 1. And then this one is also another simplification. 12 divided by 3 equals to 4. So 8 divided by this unknown number must also equal to 4. So 8 divided by something equals to 4. Well, the something is 8 divided by 4 equals to something. So 8 divided by 4 equals to what, guys? 2. So something equals to 2. We're done that section now. Now we're on the fourth section, where I'll be teaching you about a problem-solving strategy called drawing a picture. Now, I don't personally like this problem-solving strategy, but it works. There's other ways to do it though. So here's a question. An amusement park has 4 roller coasters. Each roller coaster has 6 cars. Each car has 2 wheels. How many wheels are there in total, or in all? Step 1, understand the question. What do you know? Well, the amusement park has 4 roller coasters. Each roller coaster has 6 cars, and each car has 2 wheels. What do you need to find? How many wheels is what we need to find. So step 2, we plan what we do. In this one, we must draw a picture or diagram because that is what I'm teaching you. You can draw a picture to show what you know and what you need to find out. And now we solve. So we do what our plan tells us to do. So we draw 4 roller coasters. I'm not going to draw 4 proper roller coasters. So here's what I'm going to call a roller coaster. It looks very depressing, I'm aware. Draw 6 cars on each roller coaster. Oh no, this looks like a caterpillar now. Oops! But it's okay, you don't need super duper drawing skills for this. You don't even need to have proper drawings. Oh, that looks like a shish kebab. So now we draw 2 wheels on each car. Well, these wheels are going to look like legs. Right. Count the number of wheels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So there are 48 wheels. Another way to do this would be multiplication. There are 4 roller coasters. There are 6 cars on each roller coaster. 4 times 6 equals to 24. And then there's 24 cars. And there's 2 wheels on each car, so 24 times 2 equals to 48. It's much quicker if you're used to it, but for understanding purposes, we're just going to do this. Is the solution reasonable? Yes. How can you use your picture to check your answer? Count it again. So now let's do some practice questions, except for the practice questions, I'm not going to draw them all out. I'm going to use the simple multiplication methods. There are 3 rows of 5 mini pizzas on the tray, and each mini pizza has 2 pepper slices on it. How many pepper slices are there in all? So we must ask ourselves, how many mini pizzas are there? So there's 3 rows of 5. What does this remind you of? Multiplication. 3 times 5 equals to 15. So there's 15 mini pizzas, and each of them have 2 pepper slices. So 15 times 2 equals 30. There are 30 pepper slices in all. That was much quicker than drawing little pizzas, right? So, Reshma baked 3 batches of banana bread. That's a lot of banana bread. Each batch has 4 loaves. Each loaf had 12 nuts in it. How many nuts did Reshma use in all? First of all, that's a lot of banana bread. And these are very small because that's not a lot of nuts. Anyhow, 3 batches of banana bread with 4 in each batch. This sounds a lot like 3 times 4. So that's 12, as we know. And each of these 12 loaves had 12 nuts in them. So that would be 12 loaves times 12 nuts. So 12 times 12 equals to 144. 144. So Reshma used 144 nuts. So, the next question says, oh, this one actually involves fractions. Okay, for this one I'm going to draw because fractions, we just learned them and they might be a little difficult. The quesadilla was cut into 6 pieces. It might not be a perfect 6 pieces that I'm drawing here. It isn't a perfect 6 pieces, but pretend that they are equal. Christina ate 1/3. So we know that 1/3 is equal to, well, 6 divided by 3 is equal to 2. So this divided by 1 must equal to 2. So 2 divided by 1 equals to 2. So it equals to Christina ate 2 slices. Louis ate another 1/3. So he also ate 2 slices. And Mario ate 1 piece. How many pieces were left? 1. Now, you could also do it with just subtraction. So 6 over 6 minus 1 over 3, which we know is 2 over 6. So minus 2 over 6 minus 2 over 6 minus 1 over 6. But we haven't learned subtracting fractions yet, so ignore this. Question number 4. The pencil cup needed to be cleaned out. There were 25 pencils in the cup. 12 were broken. 5 didn't have any erasers. Oh, that's sad. And the rest were able to be sharpened and used. How many pencils were put back in the cup? Now, if you are going to draw this, you are going to have to draw 25 pencils or 25 sticks and cross them out one by one. No, that's not a good idea. And on a test, this would take too much time. So, 12 were broken. So we know that we can't use 12 of them. So that would be subtract 12. And that would equal to 13. 5 didn't have any erasers. So we can't use another 5 of those 13. So 13 minus 5 equals to 8. And the rest were able to be sharpened and used. So these 8 were all able to be sharpened and used. How many pencils were put back in the cup? 8. Because that's how many pencils are left that you can actually use. Now we're done that section. And we're on section number 5. Compare fractions. Which sounds awfully like equivalent fractions, but it isn't. So you see, you can use fraction strips, but you can also use numbers. So 1/8 is less than 3/8 because 1 is less than 3. See? And 5/6 is greater than a half. Because if you make this into its equivalent fraction, which is 3/6, 5 is greater than 3. So really, you don't need fraction strips. You just need equivalent fractions. Equivalent fractions in the world of fractions is your best friend. And by equivalent fractions, I mean the denominator has to be the same. Or, if you make the numerator the same, like, say, 5/6 and 5/7, then the number with a smaller denominator would be bigger. It's confusing, right? If the denominator was the same, like then the number with a greater numerator would be bigger. But if the numerator was the same, then the smaller denominator would be bigger. So yeah, that's what you actually need to remember. You can also use a number line to tell if a fraction is closer to 1. And the closer it is to 1, the bigger it is. Because as long as the numerator is smaller than the denominator, and it's not a mixed fraction, which we'll be learning about later, then it's going to be less than 1. So you see, 1/8 is closer to 0, and 3/4 is closer to 1. Or you could just use a good old equivalent fractions method, or comparing numerator and denominator. So now let's do some practice problems. Compare, right? Greater than, less than, or equal to. I'm sure we've already learned these signs, but essentially the point points towards the smaller number, and the wider section is pointing towards the larger number. Think about it as a mouse. You want to eat more, so the mouse is chomping down on the larger one. Now, we can clearly tell that these two are equal because they're literally the same size. So this is 2/6 equals to 1/3. And then we have, this one is obviously larger than this one. So 1/2 is larger than 1/5. Oh, look, the numerator is the same. What have I been telling you? The denominator that is smaller is larger. Now, we have 4/8 and 7/8. Well, the denominator is the same. You don't even need to think for these type of questions. You just look at the numerator and see which one's bigger, and that one's bigger, because the denominator is the same. So it's written like this. Oh, another one where the numerator is the same. What's with the ones? Anyhow, 1/4 and 1/8. Is 4 smaller than 8? Yes. Is the numerator the same? Yes. So 1/4 is larger. Now we move on to 2/6 and 1/3, which is literally right up here. They're equivalent fractions. And then we have 3/8 and 1/4. The denominator isn't equal, and the numerator isn't equal. So, what do? Well, we use equivalent fractions. What does 1/4 equal to if you want it to become something over 8? Well, 4 times 2 equals to 8. So now we have to times the numerator by 2. So 1 times 2 equals to 2, and 4 times 2 equals to 8. So we have 3/8 and 2/8. The denominator is the same, so we look at the numerator and see which one's bigger. 3 is bigger than 2, so we write it like this. Yay, we're done that section, finally. Now, let's have some fraction riddles. Well, they're not really riddles, but section 6. You can use fraction model stat, or you can just use what you've learned before. We don't really actually need these. So here's an example. Find 3 over 6 and 2 over 6. So you get a bunch of 1 over 6s and you add them up. Now you might be thinking, if 3 over 6 and 2 over 6 equals to 5 over 6, why do I need these? You don't. You just add 3 and 2 together. And because it's the same number of total pieces, you don't add those. You don't. Okay. Never add the denominator. Always only do the numerator, guys. So, 1 plus 2 is equal to 3. And 4 equals to 4. So we keep the 4. And that would be 3 over 4. So is 8 equal to 8? Yes. So we keep the 8. And since we keep the 8, we don't really need to change the numerators, what's 1 plus 4? 5. 5 over 8. Easy, right? We didn't even need to count these. Now we have 1 over 6 plus 4 over 6. Is 6 equal to 6? Yes. So we still don't need to change the numerators. And we keep the denominator. So 6 and 1 plus 4 equals to 5. 5 over 6. 12 is equal to 12. So and we keep the denominator. Again. 2 plus 3 equals to 5. We add the numerator. Done. 1/3 plus 1/3. This is like saying half plus half equals to 2 over 2, which equals to 1. But the denominator stays, and we add the numerator, which is 1 plus 1 equals to 2. So 2/3. 10 equals to 10. The denominator stays the same again. And 3 plus 4 equals to 7. 7 over 10. Easy, right? Now let's get to the serious bit. Use fraction strips if needed. Are the denominators of all of these the same? Guys, come on, check it over with me, guys. Yes. Yes, they are. So we don't need to change that. We just write it down. So we'll write 8 for this one, since it's 8. 7 for this one. 5 for this one. And 9 for this one. 4 for this one. And 12. Now, 1 plus 6. 7. 1/8 plus 6/8, 7/8. 1/7 plus 4/7 is something 7th. So 1 plus 4, 5/7. 5/12 plus 4/12 equals to what 12th? 5 plus 4 equals to 9. 1/5 plus 2/5 equals to, well, what fifths? 1 plus 2? 3/5. 1/4 plus 3/4 equals to what? 1 plus 3 equals to 4? 4/4, which also equals to 1, because 4 over 4 is a whole. Now, 2/9 plus 3/9 equals to how many ninths? 2 plus 3 equals to 5. Now, you may be wondering, why don't we add the denominator? Well, you see, let me draw a diagram for you. We have, let's just use question number 11 as an example. 1/4 plus 3/4. We don't actually have the rest of the thing, so we don't add them. if this one plus this one is equal to 4/4. And now we're finally on the last section, guys. Section number 7. Subtraction. Subtracting like fractions. Now, you might be asking, what are like fractions? Like fractions are the ones that have the same denominator. The easy ones. Where you can just forget about the denominator, just put it in there, and then add or subtract the numerator. Which you can see right here. 6/8 minus 3/8 is just 6 minus 3, and then 3, and then 8. And 10/12 minus 3/12 is just equal to 10 minus 3, which is 7, and then over 12. Like fractions are very easy to do. You get into unlike fractions and they become, depends on the fraction, sometimes they become kind of painful. And now question number 3, 5/6 minus 4/6. Well, we just put 6 here as the denominator. And 5 minus 4 equals to, well, 1. And then there's 8/9 minus 6/9. So that would be 9 at the bottom. And then 8 minus 6 equals to, well, 2. Question number 5. 7/10 minus 4/10. 10 stays down here, since it's like fractions. And 7 minus 4 equals to 3. And question number 6. 9/12 minus 2/12 is 12 stays down here because like fractions again. And 9 minus 2 is equal to 7. Yay! Let's do some last practice questions. Use fraction strips if needed. Subtract. So these are all like fractions, so we really don't need fraction strips. 5/7 minus 3/7. Well, 7 stays down here. 5 minus 3 is equal to 2. 5/7 minus 3/7 equals to 2/7. If you want to think about it, well, there's a visual right up there. So 8/11 minus 4/11. 11 still there. And 8 minus 4 is equal to 4. So 4/11. 9 is 3/4 minus 1/4. And 4 would stay down here. 3 minus 1 is equal to 2. Now 2/4. Can it be simpler? Yes. 2 divided by 2 is equal to 1. And 4 divided by 2 is equal to 2. Half. Now 4/5 minus 4/5. It's the same number. It's equal to 0. If a number subtracts itself, then it's equal to 0. So we just put a big fat there. And we're done chapter 12, guys. Wasn't that fun?